So in our today's class, we are going to derive the formula for centripetal acceleration. So last few classes, last 3 days, we are studying centripetal acceleration, centripetal force, and everything. So let us see that how that formula is obtaining and deriving, and what is the methods we have to follow. This is all the things we'll discuss today. So this is actually the most important derivation also for common school exams and all. So let us see now. So keep heading everyone. Derivation of centripetal acceleration. Okay, so we'll proceed. So we all know that centripetal acceleration, what is the formula, everybody? Centripetal acceleration is equals to, everyone, v square by r, which is equals to what? R omega square. And same way, centripetal force formula. I want to know centripetal force formula. What is the centripetal force formula, everyone? Yes, please.
M square by R.
Yes. mv square by r, which is equals to what, everyone?
M R omega.
R omega square. So that is what. And according to Newton's law, we all know that Newton's law, F is equals to what? Generally, F is equals to M into A. So FC is equals to M into, what will happen? AC. So means in the sense of centripetal acceleration. Am I right or wrong, everybody?
Yes, sir.
Now observe very carefully. For deriving the formula, we are having two methods actually. So method one is a common approach and it's a very big approach. And method two is a scientific approach and it's very easy approach also. But we people need to know both the things. So let us discuss both the methods. First method, you can apply, but you have to be very attentive and you should understand everything like vector additions also we have to use it here. That is what. So first method one. Okay. So let us see that. We'll consider a first circular. Everything I will try to draw neatly and I will explain it. So your duty is to understand. So I'm taking one circle who is having a center C. So let me take it. So, and I am taking a two places, different places velocity. Let me take, this is the one place I'm taking, the first. Okay, so this is the first place velocity. Okay, it is coming like this. Okay, so I'm taking, this is a V1. So circular motion means centripetal acceleration. So we all knows that only that is changing due to the what? Magnitude or direction. Everybody, it is changing only due to the what? All of you.
Direction.
Yes.
Direction.
So that is what you should understand it. So that is the first thing. So centripetal acceleration is causing because of what? All of you? Because of? Yes, please. Direction. Clear? So this is one and this is another thing. Now I am imagining both the things with imagine just from the center, as we all knows that velocity is constant. So first imagine, so it is a centripetal acceleration. So centripetal acceleration means we all knows that only due to the change in what? Everybody. Yes, please.
Direction.
Due to change in direction. Okay. So direction of what? Velocity. Clear, everybody? So direct magnitude of velocity or direction of velocity? Everybody? Direction of?
Direction of velocity.
Direction of velocity. Because I am assuming as our assumption, please make an assumption that uniform circular motion. So uniform circular motion means who is constant, Pradosh? Uniform circular motion means something is constant. What is that? Anybody? Who is constant, guys? Magnitude of velocity is constant. That is only who is called as what? Magnitude of velocity is called something. Everybody.
Speed.
P. So V is constant. Do you remember a uniform circular motion means who is constant? Speed. You forgot it. Everybody. That is what. So V remains constant. Let me take the point. At this point, V is V1. That is what velocity is v1, and at this point velocity is v2. So now, as we all knows that speed is remains constant. Of course, magnitude of v1 and magnitude of v2 both are what? As it is, v is remains constant. Then magnitude of v1, which is equals to magnitude of v2, which is equals to how much, Ra? Which is equals to v. Am I right or wrong? Everybody understood, Pradosh? Ishali?
Yeah.
Because I am assuming as what is my assumption? What is my assumption?
Uniform circular
Circular motion. So it is speed is constant. So here velocity is v1, here velocity is v2. So the magnitude of v1 and magnitude of v2, which is equals to what? V. Because it's a only changing due to the direction of what? Due to the change in direction or due to change in magnitude? Due to change in direction. Because it is a what acceleration? Tangential acceleration or centripetal acceleration? It is centripetal acceleration. So centripetal acceleration will change due to the what? Direction or magnitude? Direction. Okay. So let us imagine here, all of you observe. I'm just joining from that. As we all know, the angle between the centripetal acceleration is acting towards to the center always. So that, what is that actually? So how much is the angle between them? Everybody?
90
degrees. That you should respond. That is what understanding is very, very important here. So let me imagine this is the point. So what is the angle between them? Everybody? I'm imagining as a angle between them is how much?
90 degree.
No, not here. Here. Let me imagine the angle is theta. And here is the r radius. And here is also r radius. And what is the angle here, everyone? I'll reduce the thickness and I'll mention. So what is the angle here? Here, what is the angle, Ra?
90 degree.
Same way here also, what is the angle? Everybody?
90 degrees.
90 degrees. Adi teriyuma? Everybody clear? Yes?
Yeah.
All of you? No. So observe very carefully. I will take an V2 and V2. Just normally, if I extended mathematics, like imagine that if I extended this one like this, and if I extended this one, then the angle between this is what V1 and this is what V2 if I extended. Okay. So the angle between them is equals to the angle between this. Understand, Rudreswar? When I'm keep on coming from this point, understand? So this is the angle as they are perpendicular, both V1 and V2, both are perpendicular to R. So whatever the angle making here between these two, which is equals to the same angle here also. Do you all understand what I'm saying, everyone? Yes. So that point also you can write. The angle between V1 and V2 are perpendicular to whom? V1 and V2 are perpendicular to something. What is that? Perpendicular to what, Ra? Both. Perpendicular to R. So the angle between them is also equals to what? Everybody. The angle between them is also equals to what? Equals to theta. Okay. So remember that. Understand, Pradosh, Rudreshwar? That is what. Now I am taking that two vectors separately. So what is the angle between them? We have assumed. Everybody, the both are equal as they are both are perpendicular to R. So what is the angle between them? All of you, theta. Understand? So this is the V1, V2. Let me take like this. So this is the V2. And this is the V1. Okay. So what is the angle between them, everybody? Yes, please. What is the angle between them? Just now I told this is V1 and this is V2. So what is the angle between them? Angle is equal to how much?
Theta, sir.
Theta. That is what you have to remember. Now, so here, as we all knows that two vectors are tail by tail is joined. So apply the triangle law of vector addition. What will happen now? Resultant vector is equals to everybody. So triangle law of vector addition. Can anybody tell me what is that? You remember that? Triangle law of vector addition. So always the resultant vector must be what? Suppose the two vectors are following. Suppose this is the one vector followed by second vector.
Opposite direction.
Then
Opposite direction.
direction of resultant vector, what, Pradosh?
It will be up.
opposite to the another one. Am I right or wrong? Everybody clear?
Yes.
Let us assume
Yes,
this
sir.
is the V1 and this vector is, let me take delta V. Then what is the resultant vector? Opposite. Same direction means like this. So opposite direction means upward or downward arrow? Everybody.
Upwards.
Upward arrow. Like this.
Upward.
Am I right or wrong? Everybody understood, Amma? Triangle of vector addition. Everybody see that. This is the initial point going head followed by tail. So that the resultant vector must come opposite direction or same direction? Everyone. Opposite direction. So this is what I am taking as a delta V, resultant vector. So now you tell me from this, what is the resultant vector? We got it, V2. Okay, so V2 is equals to sum of V1 plus delta V. Am I right or wrong, everybody? Clear? Yes, please.
Yes, sir.
So from that, delta V is equals to what? Everybody, delta V is equals to, fastly tell me, V2 minus V1. Okay, V2 minus, please respond.
V1.
V2 minus V1. Okay, now as it is delta means it is a very, very big actually. So now let us consider very small angle theta between them is a very small. So small angle, how we can represent? Theta, delta theta, d theta, small angle. Very small angle.
dV.
So how will represent? Everybody will represent with the, yes please, d theta. Okay.
D
So that is what. So let us consider this is V2 and this is V1. So again the same thing. So this is V2 and the resultant vector is now delta V or dV or everybody. dV. Okay. And this is V1. Same thing again. So the angle between them, theta, delta, d theta, theta, d theta,
D
d theta.
D
And
theta.
this is V1. So now apply the same thing, vector addition, triangle of vector addition, and tell me what will happen. V1 plus dV, which is equals to V2. From that, dV is equals to what? Everybody,
V2 minus
V2 minus V1. Okay, clear? Brothers, understand? Extremely small, very small angle. So very small angle. Very small angle, we have to represent with what? Differentiation only. Yes or no? All of you? No one is
Yes,
responding.
sir.
Yeah. So that is what you have to remember. Now let us consider again the circular motion. It's very small angle, very small angle. See, because of time, when I'm drawing directly. So now imagine the distance covered by the body, very small angle. So what distance covered by the body, let me consider as a ds. Is it okay, Rudreswa? Any problem? Okay, Priya? Understand, Amma? Everybody? This
Yes,
is
sir.
V1 and this is V2. And what is the angle between them? Everybody? D theta.
D.
Okay. So now we all knows that this is R and this is also R. If you all understand. Now let me take, as we all knows that angle between them is perpendicular. Here also what is the angle between them? Angle between them 90 degrees. Understanding? Perpendicular to each other. This is also. Now, so observe this alone. Let me take the distance traveled by this is ds. That is what resultant vector. So I will highlight this triangle. Check it here. The triangle I have. So what is the triangle? This is R and this is also R. And what is the resultant vector? Everybody?
Opposite.
ds. Am I right or wrong? Everybody clear? This part. Okay, everybody?
Yes, sir.
Yes?
Sir.
Understand, Ra? So now we have two triangles. One is from outside vector additions, another one is from inside part. So now both, if you observe, they are having a similarity. What is the similarity? Can you turn? Both triangles are what? This is d theta. So both triangles are something. What is that? Verify it.
Isosceles triangle.
Yes. No, isosceles. Verify it. Just imagine that both theta. Here and here theta is same. Then
Same.
what is that? There. What triangles? Both, just imagine the theta, like we all knows that. Imagine, just for example, I'm saying here is theta is 60 degrees. Here is theta is 60 degrees. Then there also what is the theta? Here also what is the theta equals to? Yes, please.
60 degrees.
60 degrees. Then what is that? What is that? Just example I'm saying. Just imagine theta is equals to 60 degrees. Then what will happen? Both the triangles are what? This triangle and this triangle. Everybody. equilateral triangles. Understanding? So one is, observe once again, I will draw. V1 is equals to V2. Why V1 is equals to V2? Can anybody tell me? Starting, imagine. We have imagined here. What is that? This is uniform circular motion. So V1 is equals to V2, which is equals to what?
V2 is
V1 is
equal to
equals to V2 is equals to, everybody. V.
V.
Yes or no? All of you. That is what.
Yes,
So
sir.
both the sides are equal, and this is what dV. Now here what is the angle? Angle is d theta. Now same way this I am drawing now. This is ds and this is r and this is r. Here also both are equals to what? R and R equal or not? Everybody. R and R are equal. So now verify it, everybody. All the sides are equal. Then what triangles they are? Both are equilateral triangle. Both are what
Similar
triangles? They are
Similar triangle.
similar triangles. Understanding? Because if I consider theta is 60 means here also 60, here also 60. Am I right or wrong? They both are what triangles? Similar triangles. Okay. So similar triangles having something. Can you remember and tell me from the class 10th?
same proportion.
Yes. Proportion what, brothers? Proportion of what? Yes, correct. You said what you said correct only. Ratio of,
Sir, R
yeah, ratio of
sides are-
sides. Ratio of
are
sides is
same.
what? Ratio of sides is same. So that is what you have to remember. So first triangle, what is the ratio of sides? dV by, that is what? ds by r, which is equals to dV by V2. Both the triangles, ratios of the sides are equal. dV by V2, which is equals to ds by r. Ratios of the triangles are equal. So we all knows that ds by r, which is equals to dV divided by, we all knows that mod of V2, which is equals to what? V. R mod of V1 also, which is equals to what? Everybody? V1. So can I write it here? Everybody, V. Is it right or wrong? In place of V2, can I write as a V?
Yes, sir.
Yes. Pradosh, here we have been
Sir.
made it. So we have been made mod of V2 or V1, which is equals to what? V, because it is centripetal acceleration. So speed is always remains what? Speed is always
Constant.
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 That is what you have to remember. Now, divide both with for a particular time interval. So let me consider both, actually entire one for a time interval dt, very small time interval dt. Then both the sides you divide with the dt. So what will happen? ds by r into dt, which is equals to dv by v into dt. So now observe very carefully and tell me ds by dt something. What is it? Anyone? ds by dt is something. ds by dt what will give? Differentiation of displacement. What will give? Velocity. Same way.
Yes,
dv by dt equals to something. What is that? dv by dt is equals to everybody. Acceleration. That acceleration only what acceleration? Others.
Centripetal
Acceleration only we used to call it as centripetal acceleration. So replace this ds by dt, I will write as a v by r, which is equals to dv by dt means what I can write, guys? A by v.
A by V.
That is what. Then you do the cross multiplication. So v square is equals to ac into r. Then r is equals to what, guys? R is equals to,
E
sorry,
square
AC.
divided by
V square by
No, sorry. AC is equals to, we want AC correct. Centripetal acceleration. So centripetal acceleration is equals to what will come?
V square by
V
V square by R.
Okay. So that is only the formula. Am I right, everyone? So we know V is equals to what is the formula? Fastly remember and tell. V is equals to
R omega.
R omega. You should tell, you cannot forget R omega. Then if we substitute it, AC is equals to R omega whole square divided by R, which is equals to R square omega square divided by R. RR will get cancelled. So what is the formula?
R omega square.
R omega square. One formula, second formula. Clear? All of you understand? So both the formulas we got it. So centripetal acceleration is equals to V square by R, which is equals to R omega square. So next, if you want to find FC, so we all know that FC means what? M into AC. So that's all. So M into A means what? V square by R. R equals to M into AC means R omega square. So you got the FC formula or not? Everybody?
Yes, sir.
Yeah. Centripetal force. So this is what. So here only one logic you should understand. Similar triangles, ratios of sides is same. So dv by v2 or v1, whatever it is, and ds by r, the ratios of sides are equal. So once if you imagine that ratios of sides are equal, that's all. We all knows that at the beginning, centripetal acceleration. So centripetal acceleration means what is our assumption? What we are assuming? It is uniform circular motion. So who is always remains constant? Magnitude of velocity is constant. That is only we is to called as what? Everybody. We is to called as? Yes, please. Which is called as?
Speed.
Speed. That is what you have to remember. Now, here if you notice it, then what is the direction of AC? So as we all know, direction of AC always act. What? Direction of AC always act how much, Ra? We all knows that. Centripetal acceleration always act how, what direction? Everybody. Yes. So direction of AC. So if you notice it, direction of AC. So whatever velocity you have taken. So at this point, if you notice it, so what is the angle here? How much it is? What is the angle here? Yes, please. This is a V1. So what is the angle, Ra? 90. So let me take at this point A1 cos 90. Am I right, Dreswar? So A1 not AC. So AC cos 90 how much? AC cos 90 how much, Amma? 0. So that is why. So AC into 0, which is equals to 0. So what is the centripetal acceleration along the V? Along the V, centripetal acceleration is how much?
0.
Centripetal acceleration is 0. So that centripetal acceleration only acting towards the what? Center. What you have to remember. So along the V, centripetal acceleration is 0, as it is A cos 90 is 0. That is what you have to remember. Because if you imagine like resultant force here, so this is AC cos 90 and this is AC sin 90. So always AC cos 90 0 value, cos 90 is equals to 0. So that AC is acting only towards the what? What is the direction? Towards the center. Okay, direction of AC is always what? Everybody, always towards the center. Or we can say another statement. What we can say? Along the radius. So that is why always its component along the V is what? Along the V, always it is how much? Acceleration along the component V is how much, Ra? 0. At any point, if you find centripetal acceleration here V2, or if you find centripetal acceleration here V3, everywhere along these components V bar, sorry, velocity, it is always equals to 0. Centripetal acceleration along this one is always 0. So always it is acting towards the what? Everywhere it is acting towards the, yes please, center. So that is the direction of AC. Anybody having any problem, you can ask. Do you all understand how to derive it now? Everyone? Yes. Please respond. That is what. So this is the method number 1. Now, method 2. Method 2 is very simple, and this is actually the easiest method. So we don't need to draw anything, nothing. So again here same thing. Assumption. So the same assumption. Can you tell me what is the assumption we made it in the first method? Yes, please. Uniform velocity. Sorry, uniform circular motion. So uniform circular motion means somebody is constant. What is that? Uniform circular motion. Somebody is constant. V is what? Magnitude of V is what? Magnitude of velocity is remains constant. That is only we used to say. Magnitude of velocity, what we used to call, everybody?
Speed.
Speed is constant. Yeah. Now, verify it and tell me your previous notebook. If speed is constant, some other thing is also constant. Can you tell me? That is omega. Omega is constant or not? I have taught you in our notebook. Verify it. If V is
Yes.
constant, omega is constant. Yes or no? So V is constant. Omega. What do you mean by omega, everybody?
Angular acceleration.
Velocity.
Angular.
So omega is constant. So that is what you have to remember. Now, if omega is constant, then you can see that angular velocity is constant. So if speed is remains constant, only one acceleration is present. What is the one and only acceleration is present, everybody? Only centripetal acceleration is present. What about the tangential acceleration? If the speed is remains constant,
0.
speed is constant. What about the tangential acceleration? If the speed is
Zero.
constant means definitely tangential acceleration is 0. Am I right or wrong?
Yes, sir.
Yes, sir.
Yes, everybody, that is what it is. Over. Now, we all knows that V is equals to what is the formula? V is equals to
R
R
omega.
R
omega.
R omega. Then differentiate both the sides. Differentiate means what will happen? dV by dt. Differentiate with the time dt. So the dV by dt is equals to, here what will come? dr omega
dr omega
divided by,
divided by
clear?
dt.
That is what. Now we all knows that who is remains constant here? R is, sorry, W is
R.
constant, and here R means it is the what actually? Change in displacement. dr by dt. Omega is remains constant. So as we know that, so speed is constant. So dV by dt means something. Can you tell me what is that? Change in velocity divided by time. What is that? dV by dt is equals to something. What is that, Amma? Acceleration.
Acceleration.
But acceleration only, what acceleration is here? What acceleration here? Centripetal
Centripetal
acceleration. Omega is
Centripetal
constant, so that we will get dr divided by d theta. Okay. Now remember, dr divided by d theta. R means change in displacement. Change in displacement. So change in displacement where time will give you something. Can you tell me what it will give? Anybody? ds by d
Vela-
theta. Same way. ds by d theta will give you
Vela-
what? Yes, please.
velocity.
Velocity. So which is equals to V. So that's all. So AC is equals to omega into V. Okay, va? So we all knows that next. AC is equals to omega. V means what? Already we know. V means what? V means what? R.
Omega.
V means
R
what? R omega. That's all. So AC is equals to what? AC
R
omega
omega square.
R omega square. We got the formula, one formula. That's all. Now,
Yes.
the same formula. Now V is equals to, we all knows that R omega. From that omega is equals to what?
V by
Omega is equals to V by R. That's all. So then this formula you can substitute. So we all knows that centripetal acceleration is equals to omega into velocity. So omega means what? Everybody? V by R into V. So which is equals to what?
V square by
V square by. Clear? So that is what you have to remember. Next, from this, we can say FC is equals to M into AC. So again, same thing. M into AC means what? V square by R. R, AC means what? Centripetal acceleration means omega square.
R omega.
R into
R
omega
omega.
R
square.
omega.
That's all. So you will get it. So this is how you need to solve. Whatever you want, you can solve. Both methods are very important, but this is very simplest one. Second one, just we'll imagine, like already we all knows that when V is constant, who is constant? Everybody, omega is also constant. And if the omega is constant, only we all knows that if omega is constant, centripetal, if it is speed is remains constant, we know that only one acceleration is there. What is that? Centripetal acceleration. The tangential acceleration will become 0. So then we all knows that V is equals to what? We all knows that velocity is equals to
R omega.
R into omega. So then if you proceed, we'll get the very simple way. Here dr by d theta means change in displacement, means from one point to another point. That is what equals to ds by d theta. So ds by d theta is equals to V. That is what, if you substitute, you'll get the answer. Okay. So that is how we have to solve it. Very, very important one. I hope you understand. And from morning, you all are reading physics. Yes. I want to know that. Everyone sit and read. So this is the most important derivation. You finish it. So with this chapter is over. Of course, this chapter is not over. Circular motion is not going to end. Next chapter, again, we are having a circular motion. That is what yesterday we studied depth well. Do you remember that, everybody? Depth well. Similar way, we are getting circular motion for centripetal force, centrifugal force. That is what, as I said, pseudo force, and many things. When you are taking a driving in a curved path, how you are driving, what is the factors affecting, like lot of things are there in that. That all the things will come in the next chapter. So by the time again we have to revise these all the things and we have to continue it. Okay. So now from the beginning, I hope everybody understand the derivations, both the methods, method 1 and method 2. Any doubt? You can ask. Clear? Understand? So
Yes,
very
sir.
simple it is, but you understand it is very easy. That is why I draw the diagrams very carefully. So here you remember, if you are keep on going like this and if you are keep on going like this, that is what this vectors, whatever the angle is present, as it is both V1 and V2 are with a perpendicular with R, then the angle between them is also how much it is? Angle between them is equals to theta. Okay. So that is the only thing you have to remember. If you remember that, then that's all. You will get it everything. Make assumption properly and solve very perfectly and slowly, neatly. Everybody. Okay. Those who join late also, immediately now itself I will upload it, complete it, clear it. Each and every line in NCERT you read. If you find anything new also, please read and try to understand everything, and then only you can go to next one. Okay. So that is what you have to remember. So tomorrow we have a school, actually some webinar program. So tomorrow and after tomorrow I will take time, and then Monday if possible, Monday definitely I will take the class next chapter. So be ready for that. Before that you should complete all these things and you have to be ready. Understand everybody? Can you hear me, Mr. Sai Gardi? Line to line you have to read and you have to complete all the things, and then you'll be ready for the next class. Asita, always late, be sincere and complete the works. Okay. Thank you, everybody.